Okay, so welcome to class, I guess you could say. Today, or in this lecture, is the first of a bunch on some number theory topics. In particular, this one is about divisors and the properties of divisors. Uh, so let's get a couple things straight. First, we're talking number theory. So in general, we're talking about integers. So for the most part, we're going to talk about integers. If we get to say that we're talking about integers, you can remember that we are. But in general, we're talking about integers. And the second thing is, this particular lecture has to do with divisors, what it means to be a divisor, and what it means to divide. So let's first just talk about the word divisor. What does it mean to be a divisor? Well, we say that A is a divisor of B if and only if A divides B. And I want to be extremely clear about this. Divides is the important word. I think that makes sense as long as we can all agree on what it means to divide. So the property of dividing is a pretty important concept in this unit, so I want to make sure we have a nice formal definition. So here we have it. We have, for some A and B, which are integers, we say that A divides B if and only if you can write this equation. In other words, we can find some number n such that when you multiply A times n, you get B. In other words, B is a multiple of A. That's what it means for A to divide B. And the way we write that is we just write down here A divides B, all right, with the vertical line. Okay, so let's talk about divisors. Let's try and put this to the test here. Let's see if we can find all divisors of we're just going to pick a number at random. How about 12,345, which I came up with because it's 1, 2, 3, 4, 5. Anyway, if we want to find all the divisors of that, we need to just make a list. So we're going to, start with a list, and how do we find them? Well, we might try to approach this systematically, and that's definitely a good thing to do. Especially as we go later, we'll be extremely systematic about it. But for now, let's just see if we can find some. So you look at this number, and perhaps you're like me, and you immediately notice that it ends in a 5. And hopefully you learned at some point in your mathematical career that any number that ends in a 5 is divisible by 5. So we know that in our list of divisors, we have the number 5, right? Okay, great. But let's go back to the definition here. The definition says that for something to divide, we have to be able to write it in this form. So if we're going to say, in particular, we're saying here that 5 divides 12,345, we need to find, this is our A, and this is our B. We need to find n, right? Okay, so the easiest way to find n is literally to divide. So we're just going to take 1, 2, 3, 4, 5, and divide it by 5, and I'm writing it out like long division, but really we don't have to do long division because we know that it goes in 2, 4, 6, and 9. 2, 4, 6, 9. Okay. So we have in our list of divisors 5, and actually, if we think about this, this means over here the fact that 5 goes in and the quotient is 2,469. That means that we can write 12,345 is equal to 5 times 2,469. And now that is in this form here, right? So we wrote B is equal to A times n, where n is 2,469. hopefully you notice that this sort of gives us a freebie. If we switch the order around, we get 2,469 times 5, and that means that in particular we have that 2,469 also divides 12,345. So in our list of divisors we can say 5 and 2,469, and let's see, let's keep trying. What other numbers do we know? Maybe you know the trick for 3 or 9. You know, if you add up all the digits, so 1 plus 2 is 3, 3 plus 3 is 6, 4 plus 5 is 9, 9 plus 6 is 15. 15 is divisible by 3, so we know the whole number is divisible by 3, so we know that that if we go back over here to the side, we know that 3 divides 1, 2, 3, 4, 5, or 12,345. And if we want to figure out that quotient, we can 1, 2, 3, 4, 5 divided by 3 is 4, 1, 1, 5. 4,115. So we can add to our list, we can add 3, and we can add 4,115. Okay, cool, so this is great. We've got some factors, or we've got some divisors, but the question was to actually find all divisors. So we're sort of haphazardly going through this. Maybe we can approach it more directly. So let's maybe start from the bottom. Let's say 1. Is 1 a divisor of 1,200 or 12,345? Now, this one's kind of interesting. If you take a look at the definition, based on our definition, can we write 12,345 as some product times 1? Well, the answer is obviously yes. If we let n equal 12,345, then it does. So 1, but as you're hopefully realizing, that works for any number. So we can say that 1 is a divisor of all numbers. So every list of divisors we ever come up with is always going to include 1. And since we hopefully notice that these numbers are coming in pairs, then you'll see that 12,345 is also a divisor. So we add to our list 1 and 12,345. Okay. So in general, 1 and the number itself are always going to be in the list of divisors. All right, great. Okay, so we have 1. Does 2 go in? Well, 2 doesn't go in because we know from our elementary school arithmetic that 2 only goes in if the number's even, and this number's not even, so that doesn't work. 3 we already checked. 4, well, 4 can't go in because because the number isn't even. Well, because 2 is divisible by 4. No, 4 is divisible by 2, and 2 doesn't go in, so that doesn't work. 5 we already did. 6, well, in order to be divisible by 6, it's got to be divisible by 2 and 3, because 6 is equal to 2 times 3, but this isn't divisible by 2, so it's not divisible by 6. Okay, let's go up to 7. So here's 7 is sort of the first number which, there are tricks for. There are actually some really neat tricks to figure out if a number is divisible by 7, but maybe you don't know them off the top of your head. I personally don't know them off the top of my head either. So how do we determine if 7 divides 12,345? So does 7 divide 12,345? That's our question. All right, well, the way we figure out is we just divide. So let's, again, our little notes here. 7, 1, subtract 53, goes in 7 times. 49, 53 minus 49 is 44. I'll write that down. Check. 7 goes into 42. 44 6 times is 42. Subtract 25. 7 goes into that 3 times. And we get 21, and the remainder is 4. Okay, so I think that, hold on, I'm going to check that just to make sure. Yep, okay. Just busted out my calculator just to make that didn't seem right, but it is. So anyway, the fact is there's a remainder of 4. And since there's a remainder of 4, we know that we can't write it like this. Now, what we can write that 12,345 is equal to 7 times 1,763, but then we have to add 4. That's what the remainder means. So another way of phrasing this equation is if, when you divide, you get a remainder of 0. Here we did not get a remainder of 0, so it does not divide. So the answer to this question over here is no. Okay, now we've got a list. We've got, let's see here, let's just do one more thing here. We've got 1, 3, 5, 7 doesn't work. We can keep trying. One thing you'll note, 3 and 5 are both divisors, right? So if 3 and 5 are both divisors, then if I multiply 3 times 5, I get 15. 15 will be a divisor as well, because it's the product. And 15's partner turns out to be 823. Okay, now I just did that earlier, so I just did it by division. No real shortcut for that. The important thing, though, is that when you take, if you have two numbers which already are divisors, their product, as long as it's less than the number itself, will also be a divisor. All right, great. Now, this happens to be the complete list. How do I know it's the complete list? Well, because I did this problem earlier. But if we were doing it this method, if we were just trying it, doing trial and error, just trying the numbers, we would not be sure that this is the list. We should check. We should keep going. We should check 10, 11, 12, 13, 14, all the way up to 12,345 to see if they are in fact divisors. And hopefully you can tell that that is not necessarily the most efficient way to go about this. So we're going to learn ways to approach it a little bit more systematically.